All right, welcome to Webinar Wednesday, everyone. Today we're going to talk about modernization. As you can see on the screen, your cameras and microphones are turned off just to help things keep running along. You can post questions in the chat, and Kim's going to monitor the chat as we move forward here. So, this training will be recorded and posted online. And really, I consider this more of an informational discussion than training class. But thanks everyone for joining today. So, practically every day here at the SADSCO automation team, we get emails and phone calls from customers who are experiencing situations just like what you see on the screen, right? We have downtime and, somebody is about to learn something new. And usually what they learn is when we tell them that some of this stuff that's in their control system is obsolete. There's a couple different reactions. Some people are like, "Yeah, we knew that. This was bound to happen someday," or there's other people who are completely caught off guard and shocked that they have a control system that is running on a processor or that's 20 years old. They are surprised to learn they can't buy a new processor or a new HMI module or something of that nature. And it's not something we just have sitting on the shelf. So we want to help our customers avoid these situations and keep them from getting themselves into a bad spot. So what we've decided to do is kind of just talk through what this modernization process can look like and how SADSCO can help. So first question is, what's all the concern about? And I saw some friendly names and some veterans on the call here that joined me earlier. So we've all remembered the PLCs that we've been working on, and installing since the 80s, 90s, 2000s, right? PLC2s, PLC3s, PLC5s. Even some things that we might sort of consider modern, like SLC 500s, Micrologics. Those processors are all have reached end of life and they're now obsolete. I have a note here: no spares or repairable parts. That's true in some cases. So there are some things that can still be repaired, but virtually all the new parts are gone, and we're basically living off the repair stock and repairing modules as needed. We're starting to see some of the programming tools going away as well. We haven't had PLC2 or PLC3 software, obviously, for a long time. PLC5, the RS Logix 5, is now going to be basically unsupported. It's a final version, I believe, is out now, and we won't see new versions moving forward. And obviously, as we move into new operating systems from Microsoft, new computer platforms, and so forth, sometimes it's hard to be able to get that software to run for these older systems and be able to upload programs and so forth. So programming support is becoming an issue. And then, just the people in general, the programmers, the people who install these systems and maintain them and know how they work, many of them are retiring, and the ability for customers to support these hardware platforms is dwindling quickly. It's not just PLCs, right? These VFDs, the variable frequency drives, are going obsolete too. On this slide, we're showing a 1336, a Bulletin 160, even some of the PowerFlex 40s and 70s, which are relatively modern, they're obsolete as well. Right? So the problem isn't just controllers; it's also HMIs. Lest we forget the operator interface terminals, right? Panel views. We get a lot of calls from customers with industrial PCs that have failed. And then we get into conversations about Windows operating systems and how to restore some of those industrial PCs, how to run some of this old software that's out there. Going back as far as Advisor PC, RSView, old WinView stuff, old Wonderware stuff. There's a lot of these systems that are out there running these old old operator interface terminals. And when those things go down, it's really problematic. And something I think that we see this a lot, it kind of gets forgotten. There are more and more servo motors, servo amplifiers, and coders in modern control systems, or relatively modern control systems. And these servo motors, in many cases, are you know very specific to applications. So many times servo motors can be 6 to 12 week lead times, even for standard stuff. So we really encourage our customers to think about having spare parts, and some of the spare parts that should be included are not just the drives, not just the PLCs. Servo motors are a big problem. So considering all these things, a lot of customers wonder, well, if it's not broke, why should I fix it? Right? That PLC 5 has been running great for 25 years. Why touch it? Why mess with it? Well, we've already kind of talked about some of those reasons, right? Downtime is a big problem, right? The lack of spare parts, the lack of support, right? The ability or inability, to do remote monitoring. The newer systems will allow for spare parts. The newer systems will allow for support. The newer systems have remote monitoring capabilities. So, the need to call people in the middle of the night, maybe it's better to get a phone call and be able to jump online with a processor from home, or a processor at a remote location. That capability is pretty much built into these newer processors and newer control systems. The newer processors, obviously, just like every other electronics devices or things that we use, right? The new stuff is faster, is smaller, it uses less energy. The newest versions of our processors are starting to include AI technology. So these things can learn. They can teach themselves and optimize systems on their own. And the newer systems are designed with cybersecurity in mind. When we first started putting out Ethernet processors 20 plus years ago, right, with PLC 5s, SLC 500s, and so on, there was no concern about cybersecurity. So those platforms do not have any provisions. Rockwell has done their best to update some things, but really it doesn't exist. Modern controllers, modern devices have built-in cybersecurity and ways for them to be monitored, which did not exist, before. Uh, Flexibility in terms of communication options. A lot of different ways we can connect these new controllers to each other, connect the drives. The preferred one obviously is Ethernet. A lot of things going on there. Integrated motion control and robotics. Very easy to integrate those systems together these days. Machine safety is a big advantage with the newer controllers and new control systems. And the drives with safe off features, the servos with safety features built into them, really make it easy to identify safety issues. If a machine is down on a safety issue, we can pull that information right to an HMI, instead of sending a technician running around trying to figure out which e-stop button's pulled. And there are tons of smart devices out there. All the sensors, all the things that are out there, that edge devices provide all kind of information back to us, more than just a standard on-off signal or an analog signal. We can gain a lot of information from a lot of different smart devices and integrate that into these systems. And because we have all that smart devices and all that extra information, we can have more advanced diagnostics. We can have predictive maintenance models, and a lot of different analytic options are available to us with these newer controllers. Oh, people often say, "Yeah, I get all that, but do we really need to modernize?" Well, a couple things to consider around modernization, right? First of all, are executives in your organizations, are they aware, and do they understand the risks of using this old technology? Right? We talked about a lot of what those risks are: downtime, cybersecurity issues, lack of support, and so forth. Looking into the future, right? The risk of downtime and some of those things we just talked about typically does not fund projects. Right? increased profits, right? Increased capacity, downtime avoidance, right? Those are the things that help justify a project and help get a budget assigned to a modernization project. So, will your existing systems allow you to do things like provide a connected supply chain for your customers, right? Are your drives, your servo motors that you're currently running, are they optimized for energy savings, right? A lot of concerns are out there about sustainability and so forth. And those are also ways to help justify projects. And anytime we can talk about safety, those are things that really help us to identify opportunities to get budget money approved. If we can make a machine safer, if we can provide the cybersecurity and offer brand protection for our company, that's another huge motivator. So, if you get to that point, right, what's the first step? How do we get started? So, first steps really are, identify what our obsolescence is. Go out, survey the plant, figure out what's out there and where our biggest risks are. And then understanding what the risks are and building priority, right? Which machines are the most important? Which ones could we live without? Which control system could we steal parts off of to keep another one running? All that information needs to be kind of put together in a form that you can read and look at and really understand where your risks are. And once you understand that, then you start to build a plan around what comes first. And then obviously to build that plan and decide what comes first also involves getting a budget. We work with many customers that understand the risks and the problems with these obsolete systems, but they really struggle to get budget approval. And that's kind of what we're trying to do is help our customers achieve understand the risks, understand the capabilities of the new systems, and figure out how to get money approved to move forward. But one of the things we've been doing for a long time here at Shade UNESCO is we've been doing these what we call automation assessments. We've done, I believe, probably 50 of them over the years, and sometimes it's hard for our customers to be able to justify the cost of doing that. So what we've done is come up with what we call our first step assessment. So this is a no charge assessment. It really involves a couple of simple steps. Um, you can read the steps here, but we basically would send a service specialist on site, and you as the customer get to choose your most critical machine or process, right? One, one machine or one process. The specialist is gonna work with you and someone from your maintenance team to collect the data from that control cabinet or cabinets, depending on what it is. We're going to take that information back and run it through some analyzation. We'll put together a report that really identifies the risks and obsolescence and life cycle status and all those things of the components that are in that system. Okay. What we would ask you to do then would be set up a meeting with some decision makers in your organization. We would come back in with that report and review the findings and really review that report and try to help your decision-making team build that next step. So that's kind of the concept behind the first step assessment. Once that would be done, if that value is seen there, then we would possibly the next step might be to do a full-blown automation assessment, where we would go in and do an assessment of other machines, other processes in the facility. And really what's important then is to compare that with people's storerooms. Because once we do some analyzation of storerooms and start looking at spare parts, then we find out, who has spares, who doesn't have spares. Many times, I'm sure no one will be surprised to hear that there are spare parts in most storerooms that do not have a install base in the plant. There are parts there that do not exist, and they're just extra inventory, and they're just taking up space and driving up carrying costs for that material. So all those things get identified in a full-blown automation assessment. Oh, the steps to get started with a no charge assessment would be, you can go to our website. Right now, there's a banner at the top of the screen around this modernization. A lot of you folks that were on the call probably got the email. Should be links in there to request this, and this message would go to our marketing team that'll be subsequently come to the automation team, and we'll reach out. You can contact your Shader Yesco sales rep. If your accountant who has a sales rep, you can reach out to that person, or you can contact a local Shader Yesco office. And our new phone system allows everybody to choose the automation support option. So if you listen to the menu, one of the options there is automation support, and that call will be directed to one of the automation specialists on the IA team, industrial automation team, and they'll be able to field the call and talk with you and make arrangements to get the process started. That's really just, kind of in a quick overview, the things that we see our customers struggle with, the steps they should take, and the ways that Shader Esco can help. So I don't know if there were any questions, Kim, that came into the chat while I was talking. But you're welcome to email us at Shader Esco, and it's info at Shader Esco. I don't know why it says IA team at Shader Yesco. It's info at Shader Yesco, and that information will get to us.